Most FTC teams fail to reach their potential, not because of bad robot design, but because of poor time management. Don't skip the brainstorming, because the more ideas you have at the start will set you up for more success. This video will give you a clear week-by-week roadmap for the 12 weeks leading up to your first competition. It's a structured design to help you avoid that last-minute chaos so you can show up prepared and be competitive. I'm Coach Pratt, and I've been teaching robotics and design for over a decade. I've mentored multiple teams to national championships and multiple Inspire Awards. I've seen what separates the top teams from the rest, and it almost always comes down to having a solid plan from the start. So today, I'm going to run you through an ideal 12-week timeline for FTC teams, covering what you should focus on from kickoff right up to your first qualifier. My hope is that this will give you some direction and a solid guide that you can then modify to fit your team's situation better. So before we hop into this quick, I just want to say what this list is and what this list isn't. This is sort of a good guideline or a framework for you to decide to set your season up for. It's also a bit of an ideal. It's kind of a heaven to strive for, if so to speak. If I could outline a perfect season, this might what it look like. But obviously, things are a little bit messier than that. This is also not an entire season outline. If your team is gunning for the World Championships, this is only going to get you up to your first competition. From there, it's going to be up to you to take these skills that you've learned here, redefine them, and bring them up for your next season or for your next competition after that. Obviously, with a shortened timeline and work on things you know. This is not an absolute list to follow along with 100% to the T, and if you are not following this list, you are somehow failing. Again, this is an ideal, and realistically, not every team's going to be able to hit this, nor do I think every team manages to hit this every single time. But if you follow along this, and even if you don't hit the ideal right away, you are still making those steps to move along to having a more successful season. So again, don't take this as if you're not following this perfectly. Don't take it as a failure point. Take this as we are moving towards that steps of developing in our engineering skills. So this whole list itself and this whole plan is based off of the design cycle and the idea of iterative design. So you're constantly taking your designs and you're iterating upon it. It's not designed as, version 1 of the robot, version 2 of the robot, version 3 of the robot. Get that thinking out of your brain. I want you to think about V1.1, V1.2, 1.3, and so on. You're iterating upon these designs. And eventually you may come up with a V2, but realistically, when it comes to FTC designs, most designs work. Active intakes will work, passive intakes will work, claw grapplers will work, and these have worked with just about every single season. There's a few challenges that always come back every single season, and teams that do well are teams that have taken a design and refined it to work with the piece that they are. So let's get into this 12-week strategy. This is hopefully gets you up to your first competition. So in week 1, your main goal is strategy and brainstorming. There should be basically no building until the end of the week. So the whole goal here is that you are analyzing the game manual, you're watching the release video several times, you know what the rules are, and you should be able to sort out what are the most ideal ways of getting points. Yeah, you really got to think about what's your kind of shining light for the season, and then is what will get us the most points in the least amount of time. So you need to take a look at all of the aspects that a season may have, which tasks are most difficult, which tasks are least difficult, which tasks you perceive could be done quickly, and then how might those different strategies relate to how you might go about getting more points. Look for ways that you could stop other teams from getting points. So really analyze in that game. Once you've analyzed in that game, spend a full day or two, and I spend probably 3 days just analyzing that game. Then you spend 2 or 3 days just brainstorming all the different possibilities that you could have for that. I like to use IDEO's rules for brainstorming. IDEO is the Stanford School of Design. Awesome guys. And they have 7 rules when it comes to brainstorming. And anytime you're doing a brainstorm session, you should follow these 7 rules. Defer judgment, encourage wild ideas, build on ideas of others, stay focused on your topic, one conversation at a time, be visual, and go for quantity. What I like to do with my team is we set up in a room, we grab a whole bunch of Post-it notes, and everyone brainstorms an intake for 10 minutes, and you just come up with as many ideas as you can. Then we transition over to what an outtake might look like. We come up with as many ideas as we can. We come up with what a hang mechanism might look like, or whatever the challenges are for the season that your team has aligned. We follow these rules when we're doing that brainstorming. Then you can take that brainstorming idea and synthesize into what ideas follow similar categories and so on. And then you can start coming up with some ideas for what an initial prototype robot might look like. At the end of this week, I like to run some sort of large build event, be it we do robot in 24 hours, so we do 3 8-hour sessions. You do a robot in 3 days. Some teams have popularized. But the goal is you want to have some sort of functioning robot. Take a look at Rev, take a look at Stadika robots, take a look at GoBuilda. They typically all release starter robots, and I'll also be releasing a starter kit robot this season as well. So take a look at how these designs are done, build them yourselves, and then see how they perform. And then think about how you can take those starter robots and iterate upon them. These starter robots are a great idea of starting your kind of base skill and going up from there. So by the end of week 1, you should hopefully have a functioning robot. For week 2, we're talking about hopefully having 2 different chassis if that's possible. Having a prototyping chassis and some sort of programming chassis. So you can take that robot in 24 hours bot that you've given and you can hand it off to your programmers, and your programmers can then take that robot in 24 hours robot, and then they can actually start programming on working some mechanics and see how that works. They can design it out and see and let the build team know, how are these things actually functioning? How are they performing? Are they doing what it is that you need? Build team, you can go ahead and take that robot in 24 hours and you can now start building a second chassis where you can start prototyping some more designs on top of. Your goal here is to iterate on a lot of kind of base ideas in this week. So look at your brainstorming idea and said, okay, we had 5 or 6 kind of categories of intakes that we could design. Let's build 5 or 6 really quick prototypes and see which ones might hold a little bit of weight and go from there. For your outreach team, I'd say it's time to start doing some social media documentation, as well as start developing a list of what your longer term goals are for your sustain and your outreach goals. How you might do a little more long-term goal and growth strategy. In week 3 here, you're really working on that mechanism prototyping. So the build team is still focusing on really quick, rapid prototypes. Your goal is to be bad Italian chefs here. Throw a bunch of spaghetti at a wall until you see what sticks. Yeah. If you don't know what I mean by that, that's another way of testing whether pasta is al dente, because the starches will start to form on the outside of the pasta. So when you take it out, you can throw it against the wall. If it's got enough starches on the outside of it, it'll actually end up sticking to the wall. Basically, build as much as you can at this point. And again, rapid prototypes. You can do some iterations on some things, but I focus more on different classifications of designs as opposed to full designs. Your programmers can start doing a little bit more learning in this point, because you likely have done most of your program for your mechanisms from that version 1, and you've kind of let the build team know what things are successful, what things might not be. Now's a good time to do some practice tuning on Pedro pathing or Roadrunner on that prototyping bot, and then, or perhaps getting into some more kind of more advanced tools. If you outreach team, now's a good time to continue to document that for that engineering portfolio, how things are going, as well as start planning for some sort of long-term outreach, be it mentoring a local FLL team, be it running some sort of robotics program for kids or STEM program for kids, something that is continuously developing STEM enrichment in your community. For week 4, from start to finish, now's the time to start considering your prototypes as modular units. I really like the idea of modular design, where you can have an intake that's completely isolated from an outtake, and you can kind of bolt these things on, and they're not fully integrated design. When you have fully integrated designs and that you have to take one piece fully out in order for another piece to be able to fit itself in, it makes it a lot more challenging to run maintenance and design your robot. So you really should be designing your implements. I like to think of it as an intake, an outtake, and then whatever sort of special scoring mechanisms are in there. To have them as separate units, because that makes things a lot easier for moving in. A big thing on that intake is that you're always bringing the piece into a reliable placement every single time so that outtake can move it out. So that's one of the key things you're looking for in intake, is at the end of that intake, Is it always moving that piece to a reliable position every time? And if it's not, how might you do that? For your programming, you're doing a little bit more learning. You are focusing on maybe Limelight, maybe OpenCV, maybe Roadrunner, maybe Pedro, whatever it is you feel you need to develop on your own skills in that respect. And that outreach is pretty similar to the week before. The one thing I want to say with the build team here is that you really want to be focusing on that data you have from those previous 2 weeks to let you know which prototypes might be holding a little bit more salt here. So in week 5 is where you can really start to work on refining some of those initial prototype designs. You can throw out the ones that don't make sense and you can say, okay, from my previous 3 weeks of testing, these prototypes really started to have a lot more weight to them. Let's start doing some second iterations or maybe some third iterations on these ones. Don't get hung up on, in these first few weeks, don't get hung up on, I have to do this idea because it's working well. So you don't know if another idea might be working better or not. And this is why I'm focused on rapid prototyping. You should be building a prototype in 30 minutes and testing out whether it works. You need to test a claw, literally get 2 straight beams and see if you can pick it up. Wrap a rubber band around it. Don't worry about fancy things here. Just throw stuff at a wall. Okay. Programmers, again, you're in the same phase as you were with week 4. You're just continuing doing some of that learning, maybe getting camera vision more reliable, maybe getting sensors more reliable, whatever it is. And outreach team, you're probably at this point starting your long-term outreach program, and then you're continuing to do that engagement and an engineering portfolio. So week 6, sort of about mid-weekend week is where I would say you should really decide on this is the direction we're going to go with our robot for the first competition. Because now you have the next 3-ish weeks to actually build your first competition robot. And the goal here is that now that you have about 4 weeks of prototyping designs, you've got some things that you can really start to initialize and work off of, and then make versions 3 or 4 off of some of those, V 1.2, 1.3, 1.4 off of some of those initial designs that were holding a little bit more salt, holding a little bit more weight here. You can even start beginning a little more CAD here if you need to for some of those final robo mechanisms for your first competition. The goal is that you're not really going to be having a lot of shifts in your design after about week 6, or at least major shifts. You'll definitely do some iterations, but you don't want to make too many major changes at this point. For those programmers, once the build team, and you're probably going to be working in collaboration with the build team here, talking about what your mechanisms are going to be, you can start to write out some prototype code for what those mechanisms could be. You're probably going to have a good idea on what kind of servos and what kind of logic is have to go in between, and you can start to modulate that out. And again, outreach, you're just continuing with that long term. In week 7, you're going to start taking some of that CAD and you're actually going to start building some of those prototype ones. You might be using some more finalized materials like PETG, maybe aluminum, depending on what it is that you're doing, maybe some thicker wood or acetyl or polycarbonate. And then again, really emphasizing on that modular design so that you can bolt things on. For programming team, you might still be working on modular code. You might be working more on sensor and vision data together, depending on what it is you're working on. You may also have a chance to actually start testing some of that mechanism code, depending on how quickly that build team actually sets things off. Again, outreach team, you're just continuing that documentation, and then your social media, you're also continuing that long-term outreach. For week 8, this is where sort of week 8 and week 9 for the build team, they're kind of the same. Your goal here is to finish off that first competition robot. Hopefully you can finish that first competition robot early into week 9 so that your programmers have time to actually take that competition robot, bring all that prototype code that they've been running through. Likely they've kind of been programming in parallel with your build team. So as that intake is finished, they're starting to actually run some of the prototyping test on there. And sort of their programming tests on there so that they can actually test whether these mechanisms are working as they would expect, and you can make some iterations on some of those mechanical points. But after week 9, you really don't want to be doing too much building. And even mid-week 9, you don't want to be too much building, because when you do too much building, it doesn't give your programmers enough time to actually get a chance to have their hands on the robot and really refine these out. And the reason I say that, because the last week and a half, is almost pure driver practice preparation. So I kind of think of it like a Formula 1 race. If you put me versus Max Verstappen and I'm in a Formula One car and Max Verstappen is inside of a Prius, he is going to wipe the floor with me out on a competition floor any day of the week because he is a far better driver than I am. We've seen some pretty impressive drivers with robots that you might think are less performing simply because the drivers are so good. Even if you look at World Championships last year, there's a few robots that made it all the way to the World Championships with the Rev Starter robot because their drivers and their programs had so much time to work on this and make these things reliable. So that driver practice is a really big part of that game. So in that last month, those last 3.5 weeks, you really want to have your programmers as much time with that robot as they can. And that means that you're not making these critical shifts to the robot, which is why you're spending those first couple weeks building that robot. Then you're actually taking that initial prototyping, final design in those other 3 weeks so that your programmers get 3 weeks to actually program that competition one, and then you're working on driver practice. Now, at this time, build team usually feels like they're not very useful at this point in time. And because they've handed off the competition robot, my job is done. Well, now your job is not done because now your robot is actually going to swap. So previously, you had the programmers working on that sort of prototype robot you had before, and then you were building a competition robot. Now you're going to swap robots. And now it's time to think about what sort of radical design changes could you make for competition 2, be it a second qualifying tournament, be it your regional tournament, whatever it is. Now's the time as a build team to start thinking about how can I make some major design changes to this robot if I need to make a major design change to be able to build it out. Because again, you don't want to you will not have an optimal design. But I will tell you that if you have design that works by week 9, and if it's good enough, that'll likely get you through to the next competition, provided you've given your programmers sufficient time, like 3 weeks, to program out that robot. And you give your driver sufficient time to work on that robot. Yes, the robot may not be the most ideal robot at this time, but because they've had more time to drive it and program it, it's likely going to perform better than a robot that might look ideal and have ideal mechanisms, but doesn't have the proper programming and doesn't have that driver test. So spend that last month as a build team working on CAD for your competition 2 robot. What things have you found that you want to optimize, that you want to change? Now's the time to be working through that CAD design so that you can improve for your second competition, not necessarily for your first. Yeah. In that last week, something else that I find really helpful to do as a team is to write yourself up a checklist for something you're going to check on your robot every time before a match and every time after a match. Whether belts need alignment, whether pulleys need tightening, whether you need to put set screws back in, things that are consistent failure points for your robots, you should be checking these things. I also like to have a pre-map checklist for where does the robot need to be placed, what orientations does it need to be in, what placements does your robot need to have? Does the arm need to be at this specific angle before it is that you start that? Again, this is not a completely cut in stone design, but if I had my magic wand and I threw it out, this would be an ideal season. Obviously, things take a turn, but the main kind of overall you want to look at is that first week is brainstorming and a rapid prototype. Don't skip the brainstorming because the more ideas you have at the start will set you up for more success. That for the next 3 weeks are all about rapid design, rapid iteration. Throwing a bunch of spaghetti at a wall, see what sticks. Then the next couple of weeks are about designing more for that. Let's start making a competition robot. Sorry, that should actually include week 8. Let's start designing a competition robot for competition 1. Again, this is not going to be a perfect robot. It's not going to be a world-class robot, but you'll have a lot of knowledge that you've learned from those previous 3 weeks of doing a lot of quick iterations that you should be able to have a robot that performs the game pretty well enough to get you through to the next stage of competition. Then that final month is all about finishing off that programming. Make sure you have some driver automation set up. Make sure you have a good autonomous mode with some decent pathing, and then lots and lots and lots of driver practice in that last week, maybe even that last week and a half, so that you can really perform well. In the coming weeks this year, I'm going to be releasing every Sunday before the week starts. Here's your goal for the week, effectively. So starting the first week of September, I'm going to be releasing a video every single Sunday that'll say, hey, this is what I think your team should be focusing on for this week. So you can kind of step through the season with me as time goes by, and hopefully you can follow along with an ideal FTC season. Again, whether my teams themselves were able to follow through this or not sure. But again, we can talk about what your ideals are, and we can get a little more in-depth about these things as week goes by. This is more of a big kind of season overview, but stay tuned for some more in-depth individual weeks that we can focus on. Let me know what you think about this as a week timeline. Is this similar to your timeline? Does your team do something different? I'm always curious to see what other teams are doing, and let me know in the comments down below. So I hope you found that helpful, and best of luck out there this season, and maybe we'll see each other in a competition.